Hello everybody, welcome back to Algebra. Today we're going to talk about word problems. And we've got a very special guest hanging out with us today. It's Cameron.
For the second time.
Yeah, he's just observing though. He doesn't know how to do these kind of word problems.
Yeah, I'm not even in second grade.
That's right, a little bit above your math level, but that's okay. So we're going to talk about 3 different kind of word problems today. 2 of them are systems of equations. And the third one is a percentage problem. So we're going to go through some examples and you can see how to go about solving these problems. Hope you're excited. Alrighty, so let's get started with our first problem. Now this is going to be one of those classic 2 trains are on the tracks problems that you've probably heard of in cartoons, but they never have real answers in the cartoons. Here we're going to actually get an answer. So here's the problem. It says a northbound train leaves at noon, and 2 hours later, a southbound train leaves the same station. At 5 p.m., they are 210 miles apart. Find both trains' rates if the northbound train is 10 miles per hour faster. Now, some things that we need to know before we solve this problem. Come on, marker. There we go. The first thing is we need to set up kind of a line to see where these trains are. Okay, so here's the station, okay, and for the sake of where we are on the board, we're going to say this way is north and this way is south, okay? One train is heading north and one train is heading south, okay? So we know that they're heading away from each other, and then at the end, at this 5 o'clock mark, they're going to be 210 miles away from each other. That was in the problem, so that's something we know, okay? We also know that the northbound train is going to be traveling for 5 hours. He's traveling from noon to 5 p.m. And we know that the southbound train starts at 2 p.m. because it leaves 2 hours later, and it stops at 5. That's 3 hours. So we know the amount of time each train is traveling. Good stuff. Now, the last thing we need to take into account for this problem is the fact that a rate, put that over there, and a rate is equal to the distance traveled divided by the time it takes. Now, notice that this equation here has 3 variables, and we know what one of those variables is. In this example, we know the time each train is going. So we know exactly how long they're traveling. That's important.
Yeah.
That is important. Thank you, Cameron. So now we need to find a way to make some equations so that we can solve for the other variables. Now the first one that we can do is we can say that the distance of the northbound train, so dn, and the distance of the southbound train is equal to 210 miles. We know that. Okay? Now the other thing that we know is that the rates of the trains differ by 10 miles an hour. But we want to make sure that we have the same variables in these equations. So we're going to need to do some quick little solving here. Okay? The rate of each train, right? The rate of the northbound train, we know is 10 miles per hour faster than that of the southbound train. So that means that's equal to the rate of the southbound train plus 10. Now we can use these equations over here to figure out what Rn and Rs are equal to in Ds, because we want to make sure we're using the same variables. Okay, so what we'll do is, since we've got our rate equal to distance divided by time, we know that the northern train, their rate is equal to some distance divided by 5. And that means that if we multiply this out, our distance, the distance of the northbound train, is equal to 5 RNs. And for the southbound train, we could do the same thing, and we would get that the southbound train is equal to 3 RSs. So now we can say that we have the same variables in our equations. And what we're going to do is we're going to rewrite this first one so that only r's are in there. Because we want to have only two variables. That's important. So we're going to do that real quick. So we've got 5 rn's plus 3 rs's equal to 210. And we know that Rn is equal to Rs plus 10. So now we have a system of equations that we can solve. All right, we've only got two variables, so it means we can solve for one of them. Exciting. So let's do that. We're going to plug this equation into here because an Rn is equal to Rs plus 10. So we're going to get 5 equals Rs plus 10 plus 3 RS's, and that's equal to 210. Then we're going to keep going. We'll distribute and get 5. That's not a 5. That's a weird thing.
What was that?
I don't know. That was me not drawing very well. Plus 3 RS's equal to 210. We can subtract the 50 over and add the RS's, so we get 8 RS equal to 160, and then RS would then be equal to, what's 16 divided by 8, sweetie?
16 divided by 8?
Mm-hmm.
I have no clue what it is.
What would you multiply by 8 to get 16?
2?
That's the answer. So we now know that the RS, right, the rate of the southbound train is 2 miles per hour. So we can use that information to find the rate of the northbound train. The rate of the northbound train is going to be the rate of the southbound train plus 10. So the rate of the northbound train is 12. That's right. Thank you, Cameron. And we have our answer. Because remember, the problem asks us to find the rates. And we did that. We found the southbound rate and the northbound rate. Good job, us.
High five.
High five. All right, let's move on to our next problem. Hey, we're back with problem number 2, and this is another system of equation problem. This time, it's about money. Mike, that's me, finds $280 in his wallet in 10s and 20s. If there are 4 more 10s than 20s, then how many of each bill are there? All right. So,
okay, so there is
you gonna try to solve it, Mr. Man?
for $280. You have 10 more. I mean, you have 4 more 10s than 20s.
Mm-hmm.
So
Oops.
that would mean if you had 1 second.
Can I do it real quick?
Sure.
Okay, so we know that the value of each bill is 10 and 20. So we're going to make the $10 bills for this problem. They're going to be equal to NB, and for the $20 bills, they'll be NT. Okay, so we know that $10 times the number of $10 bills plus $20 times the number of $20 bills is equal to 280. And we know that there are 4 more 10s than 20s, so that means that the number of 10s is equal to the number of 20s plus 4. And once again, we have a system of equations. We've got two variables, the number of 10s and the number of 20s, and we have an equation that deals directly with the value of those dollar bills. So now what we can do is substitute just like we did in the last equation, and we can take this NT plus 4, and we can substitute it in for NB because we know that NT plus 4 is equal to NB. Right, buddy?
Yeah.
All right. So we'll have 10 times NT plus 4 plus 20 NT equal to 280. Now this is an equation we can solve because it only has one variable. So we'll do some multiplication here. my marker's dying a little bit. There we go. Then we'll do
That
some...
does not look like an 8.
I know. We'll add some like terms together.
Oh my gosh, why does the map keep falling down?
Because you keep touching it. And then we'll divide. Okay. We get that the number of 20s is 8. So now we know that there are 8 20s. And now to find the number of 10s, we're just going to add 4 because...
Which is 12.
That's right. The number of 10s is 12. And this one's really easy to check because we can actually do the money math, right? 12 times 10 is 120 plus 8 times 20, which is 160, equals 280. So we know that's the right amount. So we found out that I had 8 20s and 12 10s. Awesome. Let's go to our final problem. All right, here's our final problem, which is a percentage problem, which is a very popular kind of problem in algebra to have percents and stuff. And our problem says a bike is on sale for 20% off. If the sale price is $400, then what was the original price? Now, this is an example where we can set up a ratio.
What's a ratio?
You'll see. A ratio is basically just a fraction. Good question, Cameron.
I think we don't get this until like 4th grade.
That's right. Cameron hasn't learned about fractions yet, but that's okay. So what we know is that the sale price was $400. And Mr. Man, when something's on sale, does that mean it's worth more or less?
Less.
Right.
And it's 20%.
That's
off.
right.
So that would mean that it's 20% less than the original price, which is 400. So
Right. Okay. Well, let's see what we have to do. So we've got $400 as the sale price, and this is the original price, which was more expensive. Now, when something's 20% off, that means that it's actually 80% of the original value. 80%, right? You're paying 80% of what the original value was, because 20% got taken off. Does that make sense?
yeah.
Okay. So if we write that as a fraction, 8 over 10, we now have a ratio. 8 over 10 is equal to 400 over something we don't know, the original price. So what we can do when you have a ratio, Cameron, and people watching at home, is something that we can do called cross multiplication. Here's how cross multiplication works. 10 is multiplied by 400, and 8 is multiplied by x. And so we get 8x is equal to 4,000. Now all we have to do is divide, and we can find out what x is. So now we got to do some division, and I don't have a calculator on me, so hold your horses, friends at home. I've got to do some division here real quick. 8 divided by 40 is 5. That's not a 5. That looks like a weird 6.
Why do you always make these kind of mistakes?
Well, because I'm writing fast. So it turns out 4,000 divided by 8 is $500. And that is how much the bike was originally worth, $500. But it was on sale for $400. Good deal. So there we have it, friends. We've solved 3 word problems that are all different things that you can learn in algebra class. And in our next video, we're going to do 3 more examples. So no worries, there's going to be more word problems coming for you to watch and learn from.
And I might try to solve some of them.
And Cameron might try to solve them too, even though he doesn't know what fractions are. He's going to give it a shot anyway, right?
Yes.
Awesome. Thank you guys so much for watching algebra.
I'm at least going to try to help.
Thank you guys so much for watching algebra. We're really glad you're watching, and we're hoping that you're learning something. Isn't that right, buddy?
Yes.
Yes.
Bye.
Bye, friends.